Do thoughts survive? Death as electromagnetic pulses in the quantum universe. An analytical discourse. Introduction. The seductive hypothesis. Imagine that every thought you have ever entertained, every fleeting image of a childhood memory, every surge of anger or love, is not merely a transient biochemical event confined to the gray matter of your brain, but an electromagnetic pulse launched into the quantum fabric of the universe, destined to persist long after your heart ceases to beat. This is the central claim under scrutiny, that human thoughts and consciousness are electromagnetic phenomena generated by neuronal activity, and that by virtue of quantum principles, they endure beyond biological death. The idea is intoxicating. It promises a form of immortality grounded not in religious faith, but in the apparently unassailable laws of physics. Yet science demands rigor, not romance. This essay subjects the hypothesis to systematic analysis across 4 domains. 1. The biophysical nature of thoughts. 2. The propagation and decay of their electromagnetic signatures. 3. The role or absence of quantum effects in cognition. And 4. The thermodynamic and informational barriers to post-mortem persistence. The conclusion is uncompromising. While thoughts do generate electromagnetic fields, these fields are local, evanescent, and irretrievably lost at death. No quantum loophole rescues them. The biophysical reality of thoughts. Thoughts are not ethereal essences. They are patterns of electrochemical activity in neural circuits. A single neuron fires an action potential, a rapid depolarization-repolarization cycle driven by sodium and potassium ion fluxes across its membrane. This electrical event lasts approximately 1 millisecond and generates a current on the order of 10 to 12 amperes. Across a population of 10 synchronously active neurons, a conservative estimate for a conscious thought, the aggregate current produces a detectable electromagnetic field. Magnetoencephalography, MEG, confirms this. The magnetic component of the field, measured outside the scalp, reaches amplitudes of 1013 to 1015 Tesla, femtotesla range. Electroencephalography, EEG, records the electric potential, typically 10-100 microvolts. These signals are real, measurable, and tightly correlated with cognitive states. Alpha waves, 8 to 12 Hz, dominate relaxed wakefulness. Gamma oscillations and Chi-T, 30 Hz, accompany attention and memory encoding. Thus, the first clause of the hypothesis holds. Thoughts are electromagnetic phenomena. However, this is a trivial truth. The critical questions are whether these fields A. Escape the cranium with sufficient fidelity to encode information, and B. Persist indefinitely in the absence of their neural substrate. 2. Electromagnetic decay, the inverse cube barrier. Electromagnetic fields generated by neuronal currents are dipolar. The magnetic field B$ at a distance ρ from a current dipole is governed by the Biot-Savart law. Bar, propto al frac. Mu Sorio, I tau lao, dl, sin theta 4 falls p rd3. The 1 round r3 dependence is decisive. At the scalp surface, r approx 0.01 thous text. The field is already attenuated to femtesla levels. At 1 meter, it falls to 10 to 18 Tesla, indistinguishable from geomagnetic fluctuations, 50 microtesla, and cosmic microwave background noise. Moreover, the skull and scalp form a conductive shield. The cerebrospinal fluid, skull bone, and skin collectively attenuate electric fields via the Faraday cage effect, while magnetic fields penetrate but decay rapidly in air due to the absence of a propagating medium. Unlike radio waves, which are sustained by oscillating antennas and propagate as $1 in the far field, brain-generated fields lack a resonant structure and collapse within microseconds of the cessation of ionic currents. Experimental corroboration. MEG signals are undetectable beyond 10 to 20 centimeters from the head without superconducting quantum interference devices, SQUIDs, operating at liquid helium temperatures. No known technology can recover a thought's electromagnetic signature at macroscopic distances, let alone after the generating neurons have undergone ischemic depolarization. Chapter 3. Quantum Consciousness, Orch-OR, and the Decoherence Wall. Proponents of postmortem persistence often invoke quantum mechanics, citing the orchestrated objective reduction, Orch-OR, model of Penrose and Hameroff. This theory posits that consciousness arises from quantum computations in neuronal microtubules, hollow protein lattices, 25 nanometers in diameter. Microtubules, the argument goes, sustain superposition and coherence sufficient to integrate information across the brain, and the collapse of the quantum wave function, objective reduction, corresponds to a moment of consciousness. If true, a thought would be a delocalized quantum state, potentially capable of coupling to the broader universe. Quantum information, unlike classical information, is conserved even in black holes, via the ADS-CFT correspondence and Hawking radiation. Could a thought leak into the vacuum? The fatal flaw is decoherence. Quantum superposition is exquisitely sensitive to environmental interaction. In a warm, wet, ion-saturated medium like the brain, 37 degrees C, 1, 2, 3 molecules, CM3, thermal noise disrupts coherence on timescales calculated by Max Tegmark, 2000. Tau /text dec. Approx /frac /c bar KB T lambda so, where tau/lambda pars is the spatial separation of superposed states. For microtubule separations of nanometer or tau text dec are approx 10 to 13 DARs, our text slower. Conscious thoughts, by contrast, require integration over 300 to 500 mAs. The mismatch is 10-11-fold. Empirical disconfirmation arrived in 2023. Researchers at Trinity College Dublin used femtosecond spectroscopy to probe microtubule vibrations. No coherent quantum states were observed beyond 10 to 20 s, even under cryogenic isolation. In vivo, the brain's thermal bath obliterates any putative quantum computation before it can influence cognition. Thus, quantum effects are irrelevant to thought. Consciousness remains a classical emergent phenomenon. Phi, thermodynamics and information, the entropy verdict. Even if we grant the impossible, that a thought's electromagnetic or quantum signature escapes the brain intact, thermodynamic irreversibility seals its fate. The second law of thermodynamics dictates that information encoded in ordered states disperses into entropy. A thought comprising 110 neural firing patterns requires 123 bits to specify fully. Once the brain ceases metabolic activity, ionic gradients collapse, membranes rupture, and the information is thermalized within minutes. Could the universe store this information indefinitely? In principle, yes. Every photon emitted by your brain during life carries a minuscule fraction of its state. But recovery is impossible. The no-cloning theorem and Landauer's principle ensure that extracting the original pattern from cosmic background noise would require energy exceeding the total output of the sun over its lifetime. The black hole information paradox offers no refuge. Solutions, e.g. holography, apply to closed systems. The brain is open, leaking heat and particles irreversibly. Your thoughts' bits persist only as undifferentiated entropy, like the text of a burnt manuscript scattered as soot. Phi. Near-death. Experiences. Neurochemistry, not transcendence. Near-death experiences, NDEs, are frequently cited as phenomenological evidence for consciousness detachment. Yet prospective studies, Parnia et al., 2014, 2023, reveal that lucid reports occur exclusively during recoverable cardiac arrest, when cerebral blood flow, though diminished, persists. E.g., flatlines correlate with zero recall. The characteristic features, tunnel vision, out-of-body sensations, euphoria, are explicable. Retinal ischemia, peripheral vision loss, tunnel effect. Endorphin surge, analgesia, and bliss. Temporal lobe hypoxia, autoscopic hallucinations. Glutamate flood, excitatory storm, mimicking memory consolidation. No verified case exists of veridical perception during clinical death. Flat EEG plus asystole and GT 10 minutes. Conclusion: mortality and meaning. The hypothesis collapses at every level. Thoughts are electromagnetic, but their fields are confined, feeble, and ephemeral. Quantum mechanics offers no sanctuary. Decoherence and thermal noise extinguish coherence before cognition emerges. Thermodynamics guarantees information loss. Consciousness is a process, not a substance, like a flame that requires continuous fuel. Yet there is a poetic coda. While your neural pulses do not echo eternally in the cosmos, your influence does. Every word you speak, every idea you share, reshapes the neural configurations of others. That ripple propagates through culture, science, and love, an immortality not of physics but of causality. The universe does not remember your thoughts. But humanity might, if you make them worth remembering.